make large number of compound, that is type of question is going to comes in examinations. Okay. And what is the reason behind this? The reason behind this is that the self-linking property of carbon, that carbon can combine with other with same carbon atoms and can combine it up to hundred of thousands of carbon atoms combining together. Okay, like if I talk about that this is the carbon atom, it can combine with another carbon atom, it can combine like this way, this way, this way, it can combine in branch, it can combine in like this ring, okay, like this in the ring. So it can combine itself in many ways. Okay, it can combine itself in many ways. So if I talk about this one, that why it is combining, the reason behind this is that why it is combining like this way, why it is combining. The reason behind this is that it it has three parts. Why? First of all, carbon is small in size. It is small in size. And what is the benefit of this small in size? And the benefit of that one is that when it is going to make bond, okay, we'll provide you the notes, and in the notes each and everything is being written there. Okay, just I'm going to explain you this chapter. Okay, so why it is what is the benefit of a small in size? That when carbon is small in size, as a result of which it is going to have 2 electron in the first shell and the and the 4 electron in the other shell. As a result of which it can combine with another carbon atoms or another elements, and because of this small size, the bonded pair of electrons that is going to make the bond here. Okay, like for example, this hydrogen atoms are combining together. So these are the hydrogen atoms that are combining together. Okay, so these bonded pair of electrons are nearer to the nucleus. They are not very far away from the nucleus now. So they are nearer to the nucleus, as a result of which the nucleus can hold them at a very strong force. So we will say that effective, the word we have to use, effective nuclear force in carbon is more than other tetravalent atom. We have to use this word tetravalent, because it does not mean that carbon is going to have the highest effective nuclear force. No. If I take the example of silicon for explaining you here, silicon. So silicon has 2 and then 8, 1, 2, 3, 4, 5, 6, 7, 8, and then 4 electrons here. So because of this extra shell, this size of the atom increases, and because of this increase in size, bigger in size, okay, because of increase in size or bigger in size, this carbon atom or this silicon atom, when it is bonding with this electrons, with this round pairs of electron, okay, or bonded pair of electron, the effective nuclear force will be less. Why? Because the nucleus is far away. More distance uh, from the nucleus, to the bounded pair of electron, to the bounded pair of electron. As a result, bond will not be stable. We will say that effective nuclear force will be less. And if the effective nuclear force is less, then the bond will be weaker. Bond will be weaker and not stable. Bond will be weaker as well as not stable. So in silicon, if I compare it with carbon, if I'm comparing the carbon and silicon, they both are tetravalent. This question can be asked in the examination, that both silicon and carbons are tetravalent. But the carbon can make large number of compounds. We have so many compounds of carbon, but in fact, we have a separate branch for the carbon's compound. That is organic chemistry we have made. So this is very important, that you need to understand that since the carbon has a small size, the effective nuclear force to the bonded pair of electron is more, as a result of which we will simply say that the stable bond is formed. But if we compare it with silicon, silicon is also tetravalent. Silicon has electronic configuration 284 and carbon has 282,4. They both are tetravalent. But due to an extra shell, this is an extra shell, the size increases. The size increases. Okay, take the screenshot of this one. Size increases. Okay, and the effective nuclear force will be less. And if the effective nuclear force is less, then you know what is going to happen. There will be weaker bond, no, and weaker bond is there, then there will be no stability. Okay, so this is the catenation property that is the self-linking property. Because of small size, tetravalency, covalent bond, okay, carbon show the self-linking property. This is a self-linking property. Linking property of an element. It is not the carbon that is going to showing the maximum, sorry, it is not the carbon that only shows the self-linking property. Self-linking property is also shown by other elements also, like oxygen in the ozone. It can link with 3 carbon atoms, like sulfur S8, sulfur atoms, 8 sulfur atoms can combine together. Like in Cl2, chlorine atom can combine together. But here you will see that, uh, here you will see that carbon can combine together in large number of compounds. Here it is up to 8, it is restricted. This is up to 2, it is restricted. But carbon, due to small size, tetravalency, and we will say that tetravalency, small size, and covalent bond, which is the second strongest bond it is going to form. It show the catenation, the self-linking property to the maximum extent. So what is catenation? We will simply say here that catenation is the self-linking property of an element. Catenation, it is a self-linking property. It is the self, okay. This is also written in the notes. Self-linking property of an element which carbon shows it to maximum extent. Okay, we need to explain it more betterly, that we have written the notes. I'm just writing a short definition. The correct definition that we have written in the notes is that that it is a self-linking property of an element to which an element can combine with its own kinds of atom. Means an element can combine to its own kind, means similar to itself, means exactly the atom which is similar to itself, like carbon atom, like chlorine atom, like oxygen atoms. And this carbon show this catenation property to the maximum extent. Why do it show? Because of small size, first of all. Okay, and the benefit of a small size is that effective nuclear force is more. Effective nuclear force is more. Bond formed is stable. Okay, second, tetravalency, because it has 4 arms, 4 covalency, we'll say. Its combining capacity is 4, that it can combine 4 atoms in a single time. So tetravalency and covalent bond. Okay, so I hope you understood this catenation. What is catenation? Do you understood, everybody? Tell me, Madiha, Samar, other students, everyone in the class. Do you understand?
Yes.
So let's move further. The next topic that I have written here is IUPAC naming. Catenations. Let's go to the allotropes first. Okay, then we will be moving to the, what is allotropes? Allotropes. If I talk about diamonds and graphites are the 2 allotropes of carbon. So what is allotropes? That you know that there can be different forms. We will simply say that carbon is not, if we want the carbon in the nature, so it is not the only graphite in which the carbon is going to occur. It can occur in the diamond, it can occur in the Buckminster Fullerene's. Okay, so we will simply say that the existence of an element in nature means, if I'm talking about carbon, so if the carbon exists in different forms in nature, okay, different forms, or we can say that the existence of an element in different forms in nature. And why what is the difference, between the different forms? Like if I'm talking graphite, so it is their different arrangements of atoms, different arrangements. Like in if I talk about in graphite, the elements are arranged like this way. Okay, elements are arranged like this way in a hexagonal patterns. But in diamond, it is arranged like in tetrahedral structure, like in tripod shape. Okay, so it is arranged like this way. Okay, so we'll talk about that in allotropes. What is allotropes? We'll say that the existence of an element in different forms in nature due to different arrangements. You have to write it, due to different arrangements of their atoms. This is the very important line that you have to mention. That the existence of an elements in nature, the existence of an elements in different forms, in different forms in nature due to different arrangement of atom. As a result, they have same chemical properties. Chemical properties, but different physical properties. Different physical properties. Okay. So the existence of an element in different forms in nature. You have to keep in mind what I'm saying here is that the existence of an element in different forms in nature due to different arrangements. Like you see that it is a hexagonal structure. Hexagonal structure. Structure. In this, each carbon atom is bonded with three other carbon atoms. Here you can see that it is two. No, it is also bonded with another carbon atom like this way. So if it is two, it will be bonded like this way. Okay, here. Like this way. Here it would be. Further, it can be. So each carbon atom is bonded with three carbon atoms. Okay. In graphite, it is bonded with three carbon atoms. Here it is bonded with four carbon atoms. Each carbon, this is further be bonded like this way. So in tetrahedral structure, tetrahedral structure, this is diamond. Okay. So in diamond and in graphite, what is the difference? What is the difference? That they in their structures of carbon atoms arrangements is different. The arrangements of carbon atom is different. In graphite, it is hexagonal pattern, and in diamond, it is tetrahedral structure. So in graphite, if I talk about that in graphite, why graphites are good conductor of electricity? So I have explained you this one, that in graphite, each carbon atom is bonded with three other carbon atoms, leaving one electron free. Okay, each carbon atom is having one electron free. Okay, so there will be alternate double bonds are going to form, like one after the other. We are going to have, in order to attain stability, the alternate double bond is formed. Okay, and because of this alternate double bond, delocalization of electron is possible. Is possible. Delocalization of electron is possible. Okay, and what is delocalization? That, for example, if we have a pattern like this, carbon single bond, then double bond, then single, then double bond, then single, then double. So after some time, this pattern will go like this. Where it is double, it will become single, and where it is single, it will become double. So due to alternate double bond, alternate double bond because this electron is participating in this bond. So after this bond will break from here and this will start participating from this one. And this is called delocalization of electrons. Because of this delocalization, they are able to conduct electricity. Okay. Understood? Understood? If you go
Yes,
through the notes for the one time, then you will be able to understand these things. Like similarly, if I talk about that, why diamond is hard? So this is a specialty of tetrahedral structure that in tetrahedral structure, each carbon atoms. Okay. If I talk about each carbon atoms is bonded with equal bond angle, that is 109.5 degrees. Here the bond angle between this one is 109.5 degrees. The bond angle between this one is 109.5 degrees. Here in this one, every angle is all the carbon atoms are arranged like this way. What is the benefit of this one? The benefit of this one is that, like, if I are having another structure like this, I'm having a square planar structure. To explain you this betterly, that here is also one carbon atom is bonded with four other carbon atoms. But in this one, you will notice that if you apply the force on in this direction, the maximum force is going to exert on this one. If you apply the force on this one, the maximum force is going to apply on this one and this one. The other will not participate in the force. But here in the tetrahedral structure, since the bond angle is same, here you see that the bond angle between this and this carbon is 180 degree. And if I talk about this carbon and this carbon is 90 degree. So because of this uneven bond angle, if you apply the force, then one or two carbon is going to exert the maximum force, other will not get. But in diamond, it does not happen so. In diamond, if you exert the force on this carbon, okay, then the maximum force will be exerted on this carbon. If you exert, so all the carbons are going to receive the same force. Understood? So tetrahedral structures, that's why diamond is hard, because there is an equal distributions of force take place because of same bond angle. In tetrahedral structure, hydral structure, uh, there is equal distribution of force take place due to same bond angle, that is 109.5 degree. And that's why it is hard. That's why it is hard. That's why diamond is hard. Why do diamond do not conduct electricity? Because in graphite, each carbon atom is bonded with four other carbon atom. Unlike the graphite, there was one carbon atom is bonded with three other carbon atom. So that free electrons help in conduction of electricity. But here, all the carbon atoms are bonded with other carbon atoms, so no electron is free. So that's why it is bad conductor of electricity. But diamond is good conductor of heat. Okay, note it down. Diamond is good conductor of heat. Diamond is good conductor of heat. Good conductor of heat. Got it? So now you understood allotropes.
yes, sir.
Okay, let's move to the next part. Next, if I talk about this one is that next topic that I have chosen is the IUPAC naming. IUPAC naming, International Union for Pure and Applied Chemistry. Actually, if I talk about IUPAC naming. Okay. IUPAC naming, generally, it is we will say that IUPAC is an organization that decided and set some rules uh, to write the name of the carbon compound. Okay, because there are millions of carbon compounds are there. So that's why we need to write their names. So how can we write their names? That is very important. So let's talk about the IUPAC. In IUPAC, what is going to happen? There are some rules. Only just keeping in mind that I'm teaching you for the 10th standard and for your board examination, I'm just going to, there are some other rules also, but I'm not going to explain you with the rules. Okay. Those only that is in your syllabus, only those IUPAC I'm going to teach you. Okay. So let me explain you. First of all, when you are going to write the name, it will be always an IUPAC name should have root, saturation indicator, prefix, saturation indicators, and suffix. Okay. These two are compulsory, means they must be. These are compulsory. For example, if we have a carbon chain, like this, and if I'm having this COH group attached to it, and if I ask you that what should be the name of this compound, okay, and if I take this compound, and if I ask you that what should be the name of this compound, so we have a root word for, we have this some root words for the number of carbons, and you everybody know, I hope this one, root word for and the number of carbon, and the root word. So if there is one carbon in the main chain, then we will take meth for that one, meth. You everybody know this one. Then if it is 2, it is eth. If it is 3, we'll use prop. If it is 4, we'll use uh, pent, sorry, bute. If it is 5, we use pent. If it is 6, we use hex. 7, we use hept. And for 8, we will use oct. Okay, and there is a saturation indicator. If there is a carbon single bond everywhere, then we'll use A and E word as a saturation indicator. If there is double bond between carbon, mark my point, I'm talking about carbon. I'm talking about carbon. So if I'm talking about carbon, then it will be, if it is double bond between, don't take this carbon or oxygen, okay? It is carbon. So if it is double bond, we will use E and E. If it is triple bond, we will use Y and E. Got it? Y and E. Now, for example, if I'm going to write the name of this compound, so this is carbon, they are the 2 carbon, we'll use eth, 2 carbon, and there's single bond between carbon, we'll use A and E. So the compound name is ethane. Okay. Like we have this compound. If I talk about to write the name of this compound, so the name of this compound will be 1, 1, 2, 3. There are 3 carbons, so prop. There's single bond between carbon, sorry, double bond between carbon atom, so it is prop E. E and E we have to use. Got it? But there are some functional group that we have to use. There are some functional group. First of all, what is functional group? Functional group. Functional group can be an atom or a group of atom. An atom or a group of atom. Group of atom attached to an hydrocarbon chain, hydrocarbon chain that determines the physical and chemical properties of hydrocarbon chain. Of hydrocarbon chain. This, for example, if I'm taking this, okay, So here you see that if I remove one H, this is propane. This is propane. Where it is propane. This is, let I'm saying this is propane. Prop means 3 carbon and single bond carbon carbon A and E. But if I remove an atom, an hydrogen from it, and if I use a functional group like alcohol, okay. So for alcohol, we have suffix word and we will use its suffix here. We will remove this E and we will use the suffix word for alcohol is all. The name of this will become propanol. Propanol. Let me explain you that first. Let me explain you that what is functional group? An atom or a group of atom. It can be an atom like chlorine, bromine, iodine. Okay, or it can be a group of atoms like CHO, like COH, like OH. So there can be an atom or a group of atom. Okay, that is attached to an hydrocarbon chain. Let's talk about that is attached to an hydrocarbon chain. Let's take. If we remove this hydrogen from it, okay, and we add OH group to it. So now this hydrocarbon chain will start behaving like alcohols. Alcohol. If I took the same and if I add COOH group to it, now because of this group, because it is a carboxylic acid group, carboxylic acid, which is a functional group, it will behave like acid. Acid. Not only this, the whole carbon chain, this whole compound will behave like an acid. So we'll say that these atoms or a group of atoms, which we are calling functional group, they are just controlling this, or they are just changing the physical as well as chemical properties of this hydrocarbon chain. So this is the definition for the functional group, that an atom or a group of atom, an atom or a group of atom attached to an hydrocarbon chain that determines the physical and the chemical properties of an hydrocarbon chain. Okay, we will simply say that an atom again or a group of atom that is attached to an hydrocarbon chain that determines the physical as well as chemical properties of their hydrocarbon chain, we call them functional group. Let, for example, writing the suffix, the functional group, okay, that is OH is a functional group and it is of alcohol. So alcohol, name of the functional group is alcohol. It is OH and it must be all. Okay, alcohol. Its suffix is alcohol. Suffix, its structure is like this, OH. If we have next one is carboxylic acid, it is COOH. Its suffix is oic acid. If we have next one is ketone, it is OCO, C double bond O. Then it would be, if I talk about this will be ketone, it will be like CO or it will be like C double bond O. And its suffix is on. And next one is aldehyde. Like we have CHO. And this is C. Its suffix is al. Al. It is all, it is al. Aldehyde is al. Okay. So let me explain you that what I'm going to tell you here by this one. Let, for example, you have 2 carbon chains. Okay. Let, for example, you have 2 carbon chain. And if you add the CHO group to it, C double bond OH like this. Here, since this functional group this carbon is of functional group. The functional group is also counted in the root for determining the root. Functional group carbon will also be counted, counted when you are writing the IUPAC. will also be counted. Functional group carbon will also be counted when you are writing. For example, there are three carbons, 1, 2, 3. Okay. So the name of this one would be prop carbon-carbon single bond in, and we will remove the E because we need to add the suffix for this one. So this is a functional group for the suffix. And what is the functional suffix for this one? We have written here that for this COH, we have oic acid. So we will add oic acid to it. Propanoic acid. The name of this one will be propanoic acid. But if we take the same chain and this time we add OH group to it. OH group to it. So now this is alcohol, but this time this alcohol don't have carbon, So its name would be according to this number of carbon, that will be eth for 2 carbon, ane, and then all. Ethanol. Okay, are you understanding this one? Are you getting this one? Tell me.
Yes, sir.
Madiha, Samar, and are you getting this one? Saman, are you there? Samar?
Yes, sir.
Okay. Okay, let's. Okay. So if I took the examples, let's take the examples. Just a minute. Let's take the example for the IPC. Just give me a minute. Let me find out the some examples. Okay. Just give me a minute. Okay. Let's have some questions over it now. Okay. Here we have some questions on the IUPAC. Let's take the examples for the IUPAC. Yes, tell me that in which of the following compounds OH is a functional group? Can you tell me?
B.
Yes, you tell. Okay.
Butanol.
B.
Yeah, tell me, Madiha,
Sir,
Adil,
B.
and B. You see here that simple here that this is OH group and OH group has a suffix as all. So tough IUPAC is not going to come in examinations. Okay. So butane, all is here. So this will be B will be the correct option, because so this functional group, which functional group it is going to have butanol? Tell me which functional group it is going to have.
Butanol is
It will be having ketone.
ketone.
This will be having alcohol. This will be having carboxylic acid. And this one, tell me this one.
Aldehyde.
It would be aldehyde. Aldehyde. Okay. Ethyne. The structural formula of ethyne is eth means 2 carbon, YNE means triple bond. So which one is the correct? Which one would be correct?
A.
Here it is triple bond also, but here it is having 3 hydrogen, which is not possible. Because the general formula of alkyne is CnH2n minus 2. So it should have, if we have 2 carbons, so it should be 2 into 2 minus 2. Okay, that would be C2. 2 to the 4 minus 2 is 2. So C2H2. So this will be A. You can check the 3 carbons, 3 valencies being participated here. So it can't be correct. Okay. Unsaturated hydrocarbons are those which has double bond and triple bond. Unsaturated means double and triple bond, means there should be carbon carbon triple bond or carbon carbon double bond, means it should have YNE at the end or ENE at the end. And saturated means that it is carbon carbon single bond, so it must have EANE, alkane, becomes alkane. So it must have alkane at the end. Okay, so which one is unsaturated hydrocarbon in this 12? Question number 12. Which one is unsaturated hydrocarbon? Tell me fast.
2 and 3.
Okay, 2 and 3. So yeah, 2 and 3. Okay, this one is correct. D is correct. Next, if I talk about this one, how many the pentane has the molecular formula this, how many covalent bonds are there? So there will be 12 hydrogens covalent bond will be there, at least 12, because the other 12 hydrogen bonds are connecting. And if we have 5 carbons, so 1, 2, 3, 4, 5, so there will be 4 bonds between them. So 4 plus 12 will be equals to 16. Got it? Because 12 hydrogens will be connected with 12 single bonds.
Yes, sir.
Do question number 18.
So is it D?
Done this one?
So question number 18, right?
Yeah, question number 18. So in the previous one, if you are not able to calculate that, if you are not able to understood that how to count the covalent bond. So it is saying C5H12. So it will be having, we have 5 carbons like this way, and we will make you know that each and every carbon can make maximum four bonds. So here it is 3 with here and 1 here. So it's 4 is over. Now it is making 1 here, 1 here, 2. So it will be making 2 here. So it is 1, 1, 2. Then it is 2 more with hydrogens. Okay. 2. Okay. And it is only making, this carbon is only making 1. So it will be connected with 3. So if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it will be 16 covalent bond. Got it? Next,
Yes, sir.
the correct structural formula of butanoic acid. But means 4 carbon. Oic acid means it must have COH group. So is it and COH group is represented like in the structure, it is represented like this way. Or it can be represented like this way, COH and double bond. So this is the carboxylic acid. Okay, they both can be represented like this way. Double bond with oxygen and single bond with OH group. Got it? So which one is the correct? Tell me.
D.
D would be the correct option. 1, 2, 3, 4. Okay. So it is but and then carbon-carbon single bond everywhere. Yes, ane. And then oic acid is this one. Okay, butanoic acid. Why it is not? Because it is having 1, 2, 3, 4, 5. It is pentanoic acid. Why it is not? Because it is having double bond here. So it is but ene oic acid, not butane. Okay, ane. It is saying ane. So carbon carbon should have single bond. Ane indicates carbon carbon single bond. So it is butene. Okay, next. Why it is not? Because it is butanol, not it is having alcohol, not the carboxylic acid. So it is butanol. Okay, got it? Understood? Tell me, understood? Yeah, then Madhya, Samar, you understood?
Yes, sir.
Next. For following the straight chain is that when we are finding the straight chain, that is straight chain. So it means that we need to start it like this way. You start, but it can be like this way, like this way. It is still a straight chain because you are not finding any way where where you can stop and you have the two way and where it is considered to be as branch. For example, like this way. So here on this carbon, when you reach on this carbon, then you will find that you can go to this way or to this way. So when you have choice, then it is branch. When you don't have choice, then it is a straight chain. Like here, there is if you come on this carbon, you have to move on this one. If you have to come on this one, you have to move on this one. If you come on this one, you have to move on this one. So there is no other chance. But if you have like this way, so it will be considered as branch because on this carbon, you have two choice. You can go either here or you can go either here. So this is a straight chain because there is no choice. This is straight chain. Here on this one, when you come to this one, here it is also straight chain. Because when you reach to this one, you will reach to this carbon. But in this one, on this carbon, you have two choice. You can go either here or to the here. So not a straight chain, D is the option. Okay. Got it? Got it?
Yes, sir.
Next, which among the following is unsaturated? So you know that double bonds are considered to be as unsaturated. So this one and this one is unsaturated. And mark my point that we have to always check the carbon carbon. If it is written like this way, so it is not a unsaturated. It is carbon carbon single bond. It is saturated. Don't check this one. Name of this compound is 26. Name of the compound. Tell me fast. Tell me fast. We don't have all day. Yeah, it will be 1, 2,
Propanol.
3 carbon here. So it would be prop for 3 carbon, carbon carbon single bond ane, and this is an aldehyde group, CHO. Aldehyde. Okay, so aldehyde has suffix al. So it is not propanol, it is a prop in al. This one, 31. Will you be able to write the functional group? Write the names of the following compounds. Will you be able to write the name? How many carbons are there? 1, 2, 3, 4, 5. So it is pent. Yes. This one. Bute. And then YNE. Okay, why butane? Because it is having three carbons between, there is triple bond between carbon atoms. Okay. This one. Tell me, Madhya, and you, Adil and Samar. How many carbons? 1, 2, 3, 4, 5, 6, 7. For 7, we use hept. And then it is going to have carbon-carbon single bond everywhere. Don't count this one. And then it is aldehyde group, CHO, heptane al. This one. Yes, Adil, why are you not responding? And you, Samar?
Sir,
1,
it's
2, 3, 4, 5.
pentanol.
This will be pent. N for carbon-carbon single bond, and it is all pentanol. Identify the names and functional groups. Okay, so let's move to the next part of this IUPAC portion. Just a minute. Just a minute. So let's talk about the IUPAC naming. Okay. So if I talk about the IUPAC name of some esters, esters are the functional group that is going to have COO. Here is R, here is R. And the salt of carboxylic acids. Salts of carboxylic acid is like, for example, if you are going to write the name of this ester, CH3, COO, C2H5. Okay. So whenever this is called the ethane, it is called O8 group. O8. O8 group. COO is O8 group. O8 group. Okay. If it is 2 carbon, then its name is eth for 2, ethanoate. Ethanoate. But we are always going to write the name of this first, which group is attached to this after O. So this is 2 carbon chain. C2H5 is 2 carbon chain. It is an alkyl group. Like we have C2H6 is ethane. Okay, ethane, eth for 2 carbon, N for single bond. But when this carbon loses one of its hydrogen, it will become C2H5. Here it is C2H6 right now. C2H6. But when it loses, it will become C. Then its name will become ethyl. Ethyl, alkyl group. Like methane, it is CH4, 1 carbon, methane. Methane. But when it loses 1 carbon, lose it one carbon, and it will become CH3. Okay, and will become ethyl. Sorry, methyl. It will become methyl. Okay, so write the name of this one first. Methyl, and then no, wait, methyl ethanoate. Okay, so if it is written like, CH3 COO CH3, so it is methyl. So right here methyl, and then ethanoate. Ethanoate. Methyl ethanoate. If it is CH3 COONA, then it is sodium, right? Sodium first, and then the name of this one is ethanoate. Ethanoate. If it is like CH3, CH2, COO, and then C2H5, then it is ethyl for 2 carbon, ethyl. And then now it is not ethanoid, it is propanoid because it is 3 carbon here. So it would be propanoid, ethyl propanoate. Okay, so rest of the part we will do in the next class. Thanks for joining this one, and rest of this one we will do in the next class. Okay, I hope you enjoy the class. But if the IUPAC is going on and the chemical properties, we will take an extra class for this one so that you can understand this topic. Okay, more betterly. Got it?
Thank you, sir.
So that's all for today. We'll meet you in the next class. Thanks for joining.